All right. You said you had questions already, Cheeto? What you got? For the first problem? Gosh dang it, we already did whole long video. So watch both. Maybe I'll do it a little. I'll do both of them a little bit differently. That way we can kind of see a different way to do it.
Oh, yes.
Excuse me. The first one's hard. I've already done it one way, and I'll kind of briefly show you that, but then I'll do it a second way for this video. And grab one. Okay. So.
Is it a two-part test?
Yes. I'll talk about the two different parts at the end so you can kind of know what to prep for both of them. All right, so here's the first one. So the way we did it earlier with that first class is we talked about what a polynomial looks like. It looks like that ugly blue thing, right? And then we said, if you don't like thinking about it that way, think about it in this red way where it's like random numbers, random exponents, right? That's a polynomial. But for our way to think about it, I think I'd rather do this. I think I'd rather think about it in terms of what is a zero? Because they give us the zeros and they give us the degree. So we didn't do this before. Before we started with the definition of polynomial, we defined that and we worked from there. But for the second way to do it, let's talk about what a degree is and work from there. What does degree mean? The highest. Not just the exponent. It's the highest exponent you see, right? And what's a zero? It's a solution or a root or a x-intercept. Okay? Solution, root, x-intercept, that's all zero. Okay. So here's what I would say for this work through. As soon as you get a zero, you can write something that starts with an F. As soon as you get a zero when you're doing long division, you write something that starts with an F. So, what? Well, just one of. If you get 1 0, you can write one factor. And you're getting factorized form, right? So if you get 1 0, you can write one factor. So it says I have a 0 of 4. Means I can write a factor of. If I have a 0 of 4, what's my factor? X minus 4. So this is kind of working backwards from what we did with the other one. In the other class. What's my other 0? Oh, wait. We should know what multiplicity means.
It's 2. That's the exponent 2.
Exponent 2, right? Boop. This is actually kind of easy. What's my other factor?
X minus 3i.
Yeah, 3i. Well, yeah, okay, so this is my other 0, right? Which means I have a factor of x minus 3i. Wait a second. They said it was going to be degree 4. This looks like degree 3. I'm missing a factor. Yo.
But like you have a negative, like imaginary, and always have like a positive as well.
If you have a negative imaginary, you always have a positive, right? And that comes from a rule called the complex conjugate rule, or the law of complex conjugates. But if you don't like remembering that rule, you know where you got that? You know what formula you got that negative from, or that I from? The I? Yeah, it came from plus or minus. And what formula has a plus or minus in it? The I came from the quadratic formula, right? Because it has that square root in it. That's where you got the I from, a negative square root. The I came from the quadratic formula, which means you have a plus or a minus square root of a negative number. That's where it came from. And if you have that plus the square root of a negative number, you better have this minus square root of a negative number. All right? But we're not done. Because they give us, if they didn't give us that one last condition, we'd be done. They give us one last condition. What do they say? The coefficient of x squared is negative 25. That sucks. You know what we got to go do? Factor, FOIL, expand, box method, all that crap. Make this thing one long problem instead of 3 individual problems. So first things first, I'm going to do this one. I'm going to do it with FOIL, right? X minus 4 times x minus 4 is
I'm sorry.
what?
X minus
Oh, is it too small? I write bigger. X minus 4. X squared minus 4x minus. I hear you. X squared minus 8x plus 16. That's that first half. What about that second half? X minus 3i times x plus 3i is x squared minus 3ix plus 3ix minus 9i squared. Anything cool happen there? Those cancel out, and your I squared turns into something special.
-1.
Absolutely. X squared minus 9 times -1. Also known as x squared plus 9. So those red things turned into these two multiplied by each other, right? We're still not done. We got to do one last distributing thing, right? So let's do this distributing thing really nice with colors. What's x squared times x squared?
So you're not gonna do it.
I would like the triple double box, like a box of 6 things. No, I'm not. I guess I could do that. No, I'm going to do this. X to the 4th. Then x squared times 9.
9x squared.
And then I'm going to change colors. Negative 8x times x squared. Cubed. Negative 8x times 9 is negative 72x. Change colors to red. 16 times x squared is 16 times 9 is 144. How'd you know that? On your calculator? Oh, nice. Oh, you've already done all this. Good job. That's awesome. Anything combined? The x4th is alone. The 3rd is alone. The squareds combined. 9 and 16 turn into positive 25. I'm running out of shapes. 7. The 72x is alone. And the 144 is alone. I know people just do underlines, but that's boring. We are almost done. We're literally I know. I get it. That's a lot of work. Why would we do that much work? I don't know. It said the integer coefficient of x squared is negative 25. What is the coefficient of x squared? Positive 25. How do we make rights wrong? Or wrongs right? We are going to multiply the whole dang thing by -1. And we're going to get our final answer of p of x better equal negative x to the 4th plus the 8 thing minus the 25 thing plus the 72 thing minus the 144 thing. And that is a pretty good answer. Yes, that is the polynomial. Now, if we want, Okay, you see that highlighted negative 25 right there, or positive 25 right there? That's the thing that told me what to do. And the reason I highlighted that, I'm going to go up here and highlight it in the problem. that highlighted 25 as a positive 25 that's attached to x squared, right? Well, now the problem told me that the coefficient of x squared better be negative 25. I only know one way to make that change. Is if I multiply by any other number in the world, it turns into something else. If I add a number, it doesn't combine with it. Like, there's no other way to make that change. Well, I guess there is. What if you added 50x squared to both, or subtracted 50x squared from both sides? You see what I'm saying? But then you don't have p of x on one side. You have p of x minus 50x squared. I don't know, actually. Don't listen to me. Just an interesting thought. Don't worry about it. I was just thinking how that would look. It would have, if we subtract it, then we have to add it on the outside. So then you'd have this whole factored form plus that thing on the outside, which is not a pawn. Don't worry about it. Okay. Ugly as it may seem. You could rewrite this, though, in what Reem said earlier. Reem said there's another way to write these things, which is called, actually, sometimes they say 3Fs. Fully factored form. Which we already kind of wrote. We already kind of wrote it. We were just missing one little aspect of it. Right? We were missing that -1 on the outside. It's free. No charge. There's no charge. It's free. It's free, though. Why would you turn down a free gift?
Just give me a second because it's my lounge.
Okay. You knew that I was bringing this. Why'd you eat lunch?
I mean, need something more than just sugar and fat.
That's very true. Yes, I
Would you
agree.
accept that too?
Yeah. I was just showing you that maybe it'd be both. Though I don't think either would be right or wrong. They're just different ways to write the same function.
Wait, I have a question. Why did you subtract 1?
I did not subtract 1. I multiplied by -1. Because the problem, when we did all the crap to work out this problem, all the foiling, all the factoring, all the double factoring, we got this black equation right there in the middle. See that right there?
Mm-hmm.
And when I highlighted the x squared term, it was a positive 25. Now, in the top of the problem, they said the coefficient of x squared better be negative 25. And I'm saying I only know one way to turn positive 25 into negative 25, which happened right here. That arrow is doing all the heavy lifting of this problem. That arrow right there is that -1 being applied and making it true. Now, here's the question. When we multiplied by -1, did we change any of the zeros? Did we change any roots? By multiplying by -1, you don't change roots, right? Guys, this is crazy. This is applying everything we've learned in every class. What does multiplying by -1 actually do on a graph? I don't care what the graph is. What? It does. -1 on the outside reflects it across which axis? Okay, so watch this. What's the only thing that doesn't change? What's the zeros don't change, right? So it's a-okay to multiply by -1. But you know what it's not okay to do? What I said earlier? No, add 50x or subtract 50x. Because that would just be like, you.
Why would you subtract?
Because it said 25, right? It says 25? No, you see the 25x squared? I was like, what if we subtracted 50x squared?
Oh,
I was saying there was another way to get -25x, but
I was just brain thinking, what's a mistake someone could make is what I was trying to work through. But no, the -1 is there because it doesn't change any roots. That's why you do it that way. Flipping it doesn't change. That's really a cool thought. Okay. Not the most important question. Oh, did anybody look and see I posted a second review on top of the first review? If you were to only focus on one from now on, it should be the second one, I would think, after this class. So, I bought too much. I bought way too much. It was so expensive, too. Donuts are expensive now. They're supposed to be like 50 cents. They're like $1.10.
I mean, like,
We'll take some.
Well, I'm close to here. There's nowhere else close to here. All right, what else we got? Y'all's day to pick a question.
Just go.
I'm not going in order.
Okay.
Number 6?
Yes.
Which one?
Any one of them.
A.
Oh, it says graph each one.
No.
I have it, but then I couldn't I
Gr-
couldn't grab it.
Yeah, graphing it takes a bit of time. All right, for real, is there one you want to do more than the others? I have no preference.
Is it cool if I get it done?
Dude, yes. Why did you not earlier?
I thought about it and I'm like hungry.
No, absolutely. Or Clutchy or two. Get two for all the help you do. No, you already had one? Oh, get one.
No. You don't deserve one.
He said no.
I thought it was all clutches. I didn't know it was actually.
No, there's donuts. There's other donuts over here too. Maple? I tried.
Just do A.
Just do A?
Or, yeah, do B.
Do B? Okay.
No, for real, or just do all.
Okay. Well, B doesn't have a lot of extra stuff.
Okay, then D.
B only has the two vertical asymptotes. No, B does. B's okay. We can do B. Here we go. Y'all ready?
Can we do B and E?
Sure. But I'll come back to E later because this isn't the most important thing on the review. But I will do it. Just I don't want to waste time doing something that's not very prominent on the test. All right, here we go. B.
So this not gonna work.
No, it is, but it's just an easy version of these.
Okay.
It's like things that are easy to factor. Like this isn't super easy to factor, right? So there were. Let's just go step by step because it tells you what to find. Let's find the horizontal asymptote. Anybody remember how to find? I'll do it in colors. Anybody remember how to find the horizontal? You just look at this right here, right? X3 over X2 reduces to X over 1 dot dot dot. So as X approaches infinity, what does X do? That one's easy. Look at that problem. You see a negative sign? No. As X approaches infinity. Oh, yeah, you're right. Y. Sorry. I don't know why I wrote X. I'm sorry. Well, it's because Y is X in this case. So what happens as X approaches infinity, it goes super big, right? Like that. As if this were my graph, as X gets super big, Y also gets super big, right? And what? Yes.
My question too.
X times X times X over X times X. How many of those cancel out? Boop 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 boop. X over.
I mean, like, isn't we look at the exponential and then then 3 and then we.
That's what I'm doing. This is just for horizontal asymptote. This is not like a solution to the problem.
You subtracted the.
Okay, I'll write it so fast.
This is just for horizontal asymptote. This is how you do it. You look at the first degree on each side, and then you see what happens. And
Is it n greater than
if top is bigger,
yeah,
goes to infinity. If bottom's bigger, goes to 0. If they're the same, goes to that number.
Is bottom bigger? Goes to-
So x2 over x3 got a horizontal asymptote of 0. x2 over x2 has a horizontal asymptote of 1. 1. Right? As y goes to negative infinity, what does x go to? Looks like negative infinity on the flip side.
And if the top is bigger.
If the
Say it again, if top is bigger, it's infinity, and bottom bigger is 0.
yes, up there. Yes. All right, vertical asymptotes. These are the easier ones. How do you find vertical asymptotes?
Like 0?
Set. No, that's vertical intercept. Vertical asymptote is set denominator equal to 0. So x squared plus 4 equals 0. Ooh, there aren't any.
There was a question, not question. Two students.
Uh-huh.
We were going over a review on, I think it was Monday, right? And we had a question like this. We're trying to find the vertical asymptote.
There aren't any.
There aren't any.
It's
So,
okay.
like, I thought that was interesting. I was like, how would that look graphing wise? And it does look pretty.
It's just a normal graph, right?
Yeah.
It's just a normal graph.
I was like,
It's allowed to be normal.
yeah.
Graphs are allowed to be just normal graphs sometimes. x squared plus 4, which means x squared equals negative 4, right? Which means x equals the square root of negative 4, which means x equals plus or minus 2i. You know where that is on the graph? I don't. Don't try to be a hero. Sorry, I got an email for a student. Let me see this real quick. Oh, retake. Because I didn't write it out. As x approaches negative infinity, guess what y does? As x goes this way towards negative infinity, guess what y goes towards? Also negative infinity. Because x was y in this case. Yes.
I don't understand how X over 1 turns into that graph. Like, how did you get the graph?
Okay. It's really not fun to think about. Because you have to think about it with not words. Or, I mean, with not numbers. But I drew the graph. And I said I was left with just x, right? Okay? As the question is, it's hard to see with just x. If it were x squared, it'd be easier. Because I could say, as x approaches infinity, what does x squared approach? Super infinity, right? Like double it, or exponentially, yeah, exponentiated infinity. So as x approaches infinity, what does this thing approach? What does y approach? Infinity. Because this is your y for this case. But I'm not writing y equals x because it's just for the horizontal asymptote. It's only for the end behavior. It's not for ever. So I'm not writing like y equals x forever. It's just saying, in the same vein, if I had 1 over x, I would ask myself, as x approaches infinity, what does y approach? Well,
It just has 1 over X. Like, what is that for?
so I can't write infinity here, right? Because our brains don't know that. But you know what I could write there? 99999999999. What number is that getting super close to? No, 1 over 99999 is not 1. It's getting super. With every 9 I add, that number gets super duper close to 0. In the same vein, because we had just x a second ago, with every 9 I add to this x, that number gets super close to infinity. But I can't write infinity there. Like, there's no.
Infinity is not a number. I don't think
It's
it's not a number. It's an idea. It's saying without bounds, like going on forever and ever, either going one way or another way, either positive or negative infinity. So it's saying if we have 1 over infinity, it's telling us that the bottom of that fraction is getting so big that we cannot say, oh, it's going to equal this. No, we can't equal infinity. Doesn't make sense.
So you just say 0.
We say 0 because if we were to try to get close to infinity, which we could get like 9,900,000,000,000 trillion. We get
9
a super big
septillion,
number.
yeah.
And the actual value would be 0. Like a trillion zeros.
That's why this
and like 1.
this arrow is doing a lot of our heavy lifting. That's why I was really careful not ever to write an equal sign with this thought process. Because as you think through what's happening at the end of the thing, I write these arrows instead of these equal signs because x doesn't ever equal infinity, but it gets super close to it. And y doesn't ever equal that infinity that x is getting close to, but it gets likewise super close to it.
One of my math professors.
Hang on, what's up?
In my idea, I got the 2i, and then I got, when you did the top 0, 3i, but it says to plot removable holes. Is that only if there's an asymptote? Or those don't count as?
Removable holes are when you get the same thing on the top and the bottom.
Oh.
And there's no common factors here. A removable hole would be like, let's look. You can see them really quick usually.
Yeah.
This one looks like it's gonna have one. This one, the bottom, yeah. So like if you break apart this, it'd be x. Wait, that one isn't gonna have one. I'm stupid. The bottom will definitely have one though, right? I don't know. I don't want to do all this factoring.
D will be an example.
X minus 3. No, x plus 3, x minus 2.
Oh, wait,
X minus 5, x plus 5. No, that one doesn't have one. I gotta find one now. I'm sorry. Oops. What? It's whenever you get a factor on the top that's the same as the factor on the bottom. Here, let's look at this. X outside of here. X squared plus 6x plus 9 What does x squared plus 6x plus 9 turn into? X plus 3, x plus 3? Boom. X plus 3. One of those x plus 3s is going to cancel, right? So we don't do anything different. We're going to graph our graph, but at that 3 right there, at that 3, we just put a little hole, and we keep going with the normal graph. Just because we removed it. It's gone. It's missing. But it doesn't affect the shape of the graph. It's just a removable hole. I don't think we see that on this test. So it's not something to freak out about. It was just a quick review of one thing we did one time ever. I mean, you should still know that that is a removable hole right there. That's a hole. That's a removable hole. It doesn't change the shape of the graph. We're going to go graph this new function that's a little bit easier. Oh, the function left over is so easy. Look at the function that's left over once you remove that hole. It's literally just x times x plus 3 and one with 1 on the bottom. That's x squared plus 3x. That's like a weird I mean, it's a parabola. It's a parabola with the intercepts of 0 and -3. Frick. Okay, fine. Hang on. This is a bad rabbit hole because we didn't finish the other thing. But this is a parabola with the intercept at 0 and an intercept at -3. And is it a happy or sad parabola? Happy. Whoops. So it literally looks like that. We're done, except for the hole that I removed. That's where was the hole at? No. -3. So instead of that, I have bloop. That.
I put that for the 2i and the 3i, so that's not right.
No, the removable hole is only when they cancel out. The 2i and 3i are not on the graph. They're nowhere on the graph. Oh, did you put holes at 2 and 3?
Yeah, at -2 and positive and negative.
Yeah. I's aren't even kind of graphable. They are just off the graph. Don't even think about it. Don't even try to think about it. Like, I'm not doing anything with that green thing. That green section right there, I'm not doing a thing with. Leaving it alone. What else can we find? X-intercepts? Oh, this one's allowed to do.
Oh, he's a cute.
Yeah.
I was like, what?
This one's allowed to do, right? I should do that in a different color. Let's do that in pink. Purple. No. Blue. What? Blue. There we go. Okay. Set the top equal to 0 to get our horizontal or x-intercepts. What do we get for this? X cubed equals -27. So x equals. No, not plus or minus.
Oh, it's
Because plus 3 would give you 3 times 3 is 9, times 3 is 27. Set. -3 gives you -3 times -3 is not 9, times another -3 is -27. We only have one x-intercept. And that is at? -3. How many roots could we have had? We could have had 3 roots, right? Huh. Interesting. We could have had 3 roots, but we don't. Okay. How many times does that 3 occur? That -3 occur? Is it a multiplicity of 3?
The -3?
I don't know. That's a good question.
How would you find out -3 multiplicity?
Perhaps long divide?
Long division.
Long division? Is that how we would find it?
What do you define?
probably.
The -3, right? Because you know that's your root. The -3 divided into what? 1, 0, 27, right? 1, 0, 27? Or did I skip another one?
No.
Oh. X squared and x. 1, 0, 0, 27. Guarantee you this is going to give us a wonky thing. -3.
This is to find out if it bounces.
Hang on. I need to not make a mistake so nobody gets extra donuts. -3 times -3 is 9. 9. -27. Oh, it gives us a 0. Because it's a root. I'm stupid. But what are we left with? The new function, right? The remaining function. So we've got x plus 3. And what goes in here? Constant number, x squared. Is that right or wrong? Because this was a cubic function? Was this cubic or quartic? Oh, good. So now we've got x squared minus 3x plus 9. And what can I do with that? It doesn't factor nice and neat, so I got to use the quadratic form. I was looking to see if it factored nice and neat. I don't think it does. So negative 3 plus or minus the square root. This is where I always make mistakes. Of negative 3 squared minus 4 times 1 times 9 all over 2 times 1. This is the quadratic formula for that second part, so we can get our other two roots and see the multiplicity of 3. Although I'm pretty darn sure it's not.
No, it is not this.
Yeah, these are going to be i's as well, right? Because as soon as I even get started, 3 plus or minus the square root of 9 minus 36 over 2. Heck, let's keep going. Let's just find them, even though they're imaginary. Let's find them. 3 plus or minus the square root of negative 20. Oh, nice. Which is 3 plus or minus 5i all over 2. That's it. We can't do anything else, right? Can we graph those 2 points?
They have an I. That means you can.
Have an eye. Can't graph them. Can't even try. Kind of graph them. Can't even try.
Not on this.
Those are roots or x-intercepts or zeros or whatever you want to call them. Okay, so if we can't graph those, then we know 3's multiplicity because those are the other two. 3's multiplicity is 1 because each of those two things took up a root, right? That's all 3 roots. 2 imaginary, 1 real. So that means 3 is just 1 root, not multiple roots, not multiplicity, multiple roots, which means it's 1, which means it's odd, which means it crosses, which makes sense with my arrows. If it didn't cross, if it bounced, I'd be in trouble. If it bounced, I'd be like, crap, how do I get back up there without crossing again somewhere else that we can't graph? Yes. Sure. Absolutely. No, this is the hardest thing. In behavior. In behavior is not fun. In behavior is what happens as x gets really, really big and really, really small. We can't look at that necessarily. Actually, on this one we can because it's easy because there's only one x. Which of those two things is getting bigger? Faster. The top gets bigger faster, right? By a factor of a whole exponent of infinity. Like, it's not just getting bigger by 27 faster. So it's not just like, oh, I'm getting big, I'm getting exponentially big, and the other one's like, oh, I'm getting exponentially big, but down 27. Technically down 23. It's not like that because this 3 is bigger than this 2, right? So the top is getting way bigger at a faster rate. And so when you divide those two numbers, you don't get an... As x gets really, really big, the top is still getting really, really big at a much faster... Out of space? We'll see. Oh, we'll see. That's why you encode in MK4 instead of MP3. Because if you encode in MP3 or MP4, you lose it all. But if you encode in, like... Never mind. Doesn't matter. Okay, what's up?
So, like, for the horizontal asymptote, like, you're just saying it's x. How is, like, x an asymptote?
X is not the asymptote. X is an indicator. Okay, let's do a little. I get that horizontal asymptotes are the worst part of all this stuff. So here's a horizontal asymptote quick lesson. There's 3 things it can be. The horizontal asymptote can be infinity in our brain. Not a number. That is not a point on a graph. That is an asymptote. Or you could think of that as none. There is no horizontal asymptote. The horizontal asymptote can be a number, or the horizontal asymptote can be 0. There's only 3 things it can be.
Oh, okay.
It's infinity if the top is bigger. Because if the top is bigger, it's skyrocketing. It's just as we plug infinity into the top and the bottom, the top wins. It's a number if they're the same. Same exponent. Because as x is going to infinity, y is going to infinity at the same rate. So if you divide them, it just turns into whatever number that was. And if the bottom exponent is bigger, it's going to 0. Because no matter how hard the top one tries, the bottom one's going to yank it down and say, nope, you're coming with me. Same way, if I divided a pizza into an infinite number of slices, how much pizza do you get? Maybe that's a better way to think of it as pizza in fractions. Yeah. If you think of this as pizza with a fraction, right? This is a rational thing. And you've got a pizza, right? Where the top is the slice number, right? And the bottom is the whole. Okay. And if I cut a pizza, this is not good. Because I was going to say, if you have an infinite number of slices, that's a good thing. Still.
Well, I guess the way I do it is if you have a whole pizza and you have to serve it to a certain amount of people, you can do that, right? That's okay. But the more people that you have to give one box of pizza to, the less amount that they're getting. To the point where if you have an infinite number of people, there's gonna be no pizza to give out because just won't be. I guess that's how we use that pizza analogy, sort of.
Is the one supposed to be bigger?
No, I'm telling you the right thing. The pizza analogy just doesn't work great.
Yeah, that's kind of the
As I look at the pizza analogy for in behavior, it doesn't work great. And I wish it did. Because if x goes to infinity, this number goes to 0. But I don't know. The pizza analogy doesn't work great.
The 9 was working.
What?
The 9.
The 9. Yeah. As the whole pizza goes to infinity, and you get one slice, your slice should be getting bigger. But it's not. We know that. You see what I'm saying? Oh, that's not true. The bottom is the number of slices. And the top is how many you get. Right? That's what we always say with pizza. How many you get. Now it makes sense. You get one slice. I'm going to cut this pizza into 1 million slices. Your thing just went to 0, right?
Yeah.
That's the first thing. I cut this pizza into one slice. So that's the pizza is one whole slice. You get, okay, as x goes to infinity, this is good. Oh, I'm glad that could have taken me way longer to think out than it just did. That's how we always do the pizza thing, right? We take a fraction and we say, you get this many slices. The pizza has 8. You want 3 out of 8 or 4 out of 8? Obviously, you want 4 out of 8. Okay, so you get one slice. I'm cutting this pizza into infinity slices. This one pizza, cutting it infinity times. How big is your slice? It's 0. That's why that one's 0. This pizza's got one slice. Whole pizza, one big slice. That's the whole pizza. You get a whole pizza. You get infinity pizzas. How much pizza are you getting? A crap ton, right? Okay. You get infinite slices, but I'm also going to cut it infinity times at the same rate, where it's going to end up working its way down to you get the normal slice, right? You get infinite slices. You get as many slices as you want. But for every slice I give you, I'm going to make another cut. We're going to end up at 8/8 or 1/1. Okay. Whoa, ugly. Yes. Yeah. This asymptote, it does go to 1.
So it's always 1.
No, because if it were 2x over x, it'd go to 2.
Okay.
Because that's how many slices you just got. I think I have too many things open. Still recording? Yep. Sorry about that. People at home and people here. All right, get a different question. This is not worth spending all our class time on, I promise. I should not have done as long as we did.
Wait, so when they say, on that question, when they say consider the following functions, it's want us to answer them questions like the horizontal asymptote.
Yeah. It just says, if you get a rational, can you do all that crap?
Okay.
But, again, not our priority at all, even a little bit. Where's this thing at? I don't even know. What? This thing is just gone. This app is literally just gone.
It just disappeared.
The app, every indication of this app existing What on earth? Oh well. We'll go find something. Alright, find a different problem. Let's go. We don't have a lot of time. But we do have a lot of problems.
Like,
8. Alright, test 2 review. Oh, there it is. Boop. Number 8. Oh, perfect. This is a good one. Wait. Find the domain of that? That's the one? Cool. Find the domain of a rational function with a square root on the bottom. All right, well, we need to ask ourselves that domain question that we always ask. And now, instead of having 2 conditions, we have 3 bad things. We always ask ourselves for bad numbers, right? Now we've got 3 bad numbers instead of 2. So let's ask ourselves, what are the bad numbers? Bad numbers. What are the things that they're, if you want to know the real word, it's domain restrictions. What are the restrictions we can impose on the domain? What? Cannot be 0 where? Okay, 1 over 0? Bad. You said negative? Negative for what? Negative number? The total value underneath the square. Yes. Underneath the square root. But there's a third bad thing. Not for this problem, just in general, there's a third bad thing. Yeah? Oh, no. I'm sorry. That's a thing sometimes. I'm so sorry. That's a thing. Sometimes when you're writing a string of things and you do this, that means bad. Or I've found a contradiction. But sometimes they do this. But I should just leave it here and just say bad numbers. There's 3 of them. Bullet point 1. Bullet point 2. Bullet point 3. What's the third thing? Sorry. ln of 0 or less, right? I should say ln of 0 or ln of a negative number, right? Those are all bad. Okay, but that doesn't happen this time. It's just worth you remembering. Those are domain restrictions. But in this case, I only see one of those apply. Actually, wait, no, I see 2 of them applying. A negative under a square root and a 0. So which one do you want to do first? Negative under the square root? Dope. Let's do it. Okay. It's so much easier than you think it has to be. It really is, I promise. The thing under the square root has to be bigger than 0, right? So how do we write the thing under the square root has to be bigger than 0 in math speak? Yeah, right? You just write the thing under the square root, and then you write, and then you ask yourself the one question, can it also be 0? Why not? Can't it be 0? No, it doesn't. What's the square root of 0? Yeah, I know. We'll do that later. we'll come back and grab that restriction. But you are right. If you want to mash them together, no, I was saying I could just mash those 2 restrictions together. Because can it be 0 in this specific case? No, because of the denominator, right? Not because of the square root, but because of the denominator. So now I was like, oh, I can just kill 2 birds, 1 stone. Cut out that thing. And I'm okay with that. 100%. But if you want to do it as 2 different cases, also okay as well. All right. And then, now we got to do this normal like. Can I rewrite that so it looks normal for us? Negative x squared minus 2x plus 4. I just didn't want to. You know what we need to do? Not yet. I divided it all by -1, yeah? Divide it by -1. And when you divide by negative, what do you have to do? Flip the sign. If you don't like that, you know what you could have done? Just subtracted them all over, and you would have gotten the same thing. If you subtract them all over, technically the sign flips, because now they're on the other side of the sign. So if you like seeing it that way better, here's what I was just saying, sorry. If you like seeing it this way better, feel free. Like, this is the way that my brain saw it to start. I was like, oh, I want to move all these over so that the x squared is positive. So I'm going to go like literal plus x squared plus 2x minus 4. You see what I'm saying? And I didn't flip the sign here, but But I ended up with the 0 over here, the same sign, and all this crap on this side, x squared plus 2x minus 4. Well, that's the same thing, right? Yeah, you can just mirror it if you want to. But two different ways to prove that this is true, that you flip the sign when you divide by a negative. That's the proof of that thing, I guess, with specific numbers. We're not done, though. I think we can factor this without doing the quadratic formula. Yay or nay? 4, 1, 2, 2. No, you're right. Sorry. Dang it. It's worth a shot. Ugh. Do we have to quadratic this thing?
You have to.
Ugh, fine. I hate this. Why did I give you such hard numbers?
Yeah, and that's hard too.
I'm sorry. -2 plus or minus the square root of 4. Skip a step. Minus 4 times 1 times -4. Oh no, this is gonna be good. -2 plus or minus the square root of 4 plus 16. All over. Oh, why did I write 2a? 2 times 1. All over 2. -2 plus or minus the square root of 20. All over 2. -2 plus or minus 2 square root 5. All over 2. -1 plus or minus square root 5. I'm so sorry that I gave you all that. So those are your two roots?
Yeah.
Right? Did we have a third root or not? Nope. Those are your two roots. So I draw my number line. Because I'm looking for domain. Domain is what can x be? What? That's the x-axis, right? And I plot those 2 points. I don't know. I promise you they won't be that hard on the test. No, not. What do you mean 1 and 3? No, we're doing -1 plus the square root of 5, -1 minus the square root of 5. Where are these at? What is the square root of 5? Like 2 point something? So this is 1 point something, right? What is it? What did you say? Oh, I thought you knew the square root of 5. I don't know it.
You know how I think of it sometimes too? So like the closest perfect square root of 5 is
4.
And square root of 4 is 2.
Yeah.
So then you have -1 plus 2, which is 1.
1.
And since you know you underestimated it, you just go
Up. Up to the right. To the right is what I should have said. So let's call these. What's the other one going to be? A negative? So I'll call this one 1. We'll go right here. Can it include that point? No, it cannot include that point. Open circle. Also, sometimes you see it as that curvy line, right? Both are good. Well, actually, we don't know which way it goes yet. We need to plug in some points in a second. So I'm going to undo that. And then -1 minus that would probably be like a -3 point, right? So 0, -1, -2, -3. Open circle there. What? It can be negative. We don't know yet. We got to plug in some numbers. Let's plug in easy numbers, not hard numbers.
Why can't you just draw it?
Because we don't know which way it goes. Does it go in the middle or does it go on the outsides? Do we draw this? Or do we draw this? We don't know. We have to plug in the easiest numbers we can find. Now, granted, on the test, I promise you, I'm going to give you 1 and 3 as your points, not -1 square root of 5. Like, I promise you it'll be easy numbers. But the process is still the same. The original equation.
Oh, that was good right now.
Yeah. So let me plug in 0. See what happens. If I plug in 0 into the original equation, what do we get? 1. Are you sure?
Yes.
Oh, yeah. Is that good? Is that a good number? So can that be included in the domain? Sure thing. So I think I'm already done. I think I'm done. Okay? But to be safe, let's check some exterior things, right? So what can we check? If that's like 1 point something, we could just check 2, right? Check 2. Oh, so go up here and let's plug in 2 and see what happens. 1 over the square root of 4 minus 4. Yeah, we can just do that in our brains, right? Minus 4. Oh, what happened there? Negative under the square root. That's bad, right? So in whatever other color, you can just go bad, 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 bad. Let's check 3. Well, we can't check. Where's that point at? Like negative 3 point something? Oh, which actually should have been. If I wasn't bad at math. Somebody could have called that for a donut. Over there. So we got to check negative 4, huh? So 1 over square root 4 minus 2 times negative 4 minus negative 4 squared. I can already tell. That negative 4 squared is doing a lot of heavy lifting. That minus 16, that's going to kill us. 1 over the square root of 4 plus 8 minus 16. 12 minus 16, negative number, bad. Plug and chug. Came and did that one. You have questions? What's your questions?
So, how do you want us to express our answer?
Oh, yeah, we didn't do that yet. Sorry. So we got our domain. So your domain is, there's 3 ways you can write it, right? You can write with the parentheses. Negative 3, 2. Oh, it's not negative 3. In this case, it's negative 1 minus square root 5, comma, negative 1 plus square root 5.
So we can use intervals.
Interval. Yep, you can use interval. That's interval notation. The other way is the little set notation. X is a number that's in between that and that. That's called set notation. And actually, I lied. I think that's it.
You can graph it.
We're not going to graph it. You could graph it.
I mean,
You could graph. You could
that's
100%
what I would do. Just graph the
graph the whole function.
like the parabola and just select. Whatever.
Oh, yeah,
You
yeah,
know
yeah.
what I'm saying?
I know exactly what you're saying.
Could you just put also like the inside part of the set builder notation?
Yeah, but they've really started pushing us to start now putting it in set notation. If you're going to write it in whatever that would be, less than or equal greater than notation, they've started saying, no, put it in a set.
Set.
So we know it's a group of numbers and not just a restriction on that group of numbers. That would be a restriction if I gave you that in a problem, not the set of numbers that is those things. What? Sure thing. Thank you. Oh yeah, good question. This is a good one. Like I said already though, Phil apps. I'm gonna post. I've already uploaded the video. I'm gonna post the 2 hours from the other class. So if you want to go and watch other problems, feel free to go watch that. I'll also post this thing we're doing, even with all of our tangents and mistakes that I've made. All right. Lots of laws of logs. If you had a free response section on the test, and the free response section literally just said, list, I'm not writing this, list as many laws of logs, exponents, e, and ln. That's the only things we've done, right? Yeah, those 4 things. List as many laws as you can about those things.
Wait, you said 7?
Yeah.
Is it version 2 or version 1?
Oh, did I grab the wrong 7?
Yes.
Oh, well, this is still a good note to me to make right now. If what? Yeah, but if this was on a test, you should be interested in just making a list of all of the laws that you can remember, and then perhaps making up a problem that has those. So let's, for example, and then I'll move to the real 7. If one of the laws is any law in the world for all 4 of those things, what's a law? If you subtract them, you're dividing. So log of A minus log of B equals technically log of A over B. And then on the side of it, it said make up a problem. it would behoove you to know the law so you can make up a really easy problem. The easiest problem would be like log of 10, right? If you know the laws, you can make up super duper easy problems. If you don't know the laws, then maybe you get a little stuck, right? But 2's not right either. No, you're right. You get 2 over 10. Log of 10 minus log of 100 equals, and then you'd use that formula and probably get log of 10 over 100, which is a log of 1 over 10, which is -1. Because I went really fast. I'm sorry. Y'all made up the numbers, though, not me. I would have said 100 over 10. I would have said 100 over 10 if I were making up this problem. Yeah, because it'd make your life easier, right? So if you on the test, you might be asked to make up your own problems. The better you know the law, the easier of a problem you can make up. Right?
And the good news is, like, if you know let's say you know the laws of the logs, you'll know the laws of the natural laws.
That's true. They're all the same, but with ease instead of tens. That is true. Okay, but the real 7 that you were asking for, and we can go back to that if that's confusing, was on the other one. Where am I? I'm lost. Wait, that was on it.
No, the version 1.
Oh. Ah. Man, y'all like these inequalities. I don't like these inequalities. What am I doing? Paste. Boop. You just got to get X by itself, right? Did you already have one?
No.
Oh, okay. She's really lying. There's plenty. I don't know why I'm being mean. Let's see. We got to get X by itself, right? Done? You just leave it up here. So what's the not? I shouldn't say obvious. That's such a mean word. You want a donut? Take one. What is the thing you can do to get X by itself? Yeah. There's so many X's. There's 3 different ones, and we got to mash them all together somehow.
Multiply by 2x plus 5.
Yeah, I think so. I hate fractions. You hate fractions. We all hate fractions. Yeah. But before we do that, we must make a note. We must make a note that X better not be what? Oh, the bottom better not be 0. The bottom better not be 0, which means X better not be 2.5? 5 over 2? I was going to write does not equal, but it does equal. So I'll just write it twice. X does not equal 5 over 2. I was going to write does not equal 5 over 2, but 2.5 does equal it. It just doesn't equal X. So technically the right way to write that would be this. But I don't want us to be confused. Okay. That's just a note to make as we got rid of that removable hole, technically. Is we've got a hole there in our domain.
Is it possible if we make X like this one I did, is that I minus X from the left side?
To the right side, got a common denominator.
Yes.
You'll end up in the same spot. Yep, you'll get it right. 2x squared minus 5x less than or equal to 6 minus x.
Oh, it doesn't have to be plus 5? It doesn't have to be 2x plus 5?
That is when we have the I to get rid of the I. This is not that. If you did plus 5, look. If you did plus 5, it wouldn't cancel this out. Because the number has to, you know what I'm saying? That's not the same thing to cancel something out. A number over itself cancels each other out or turns into 1. That's a good question, though. Conjugate, that plus 5 thing happens when you see an I. You got to multiply by conjugate when you see an I. Because what that does is gets rid of the I. Turns into an I squared. Okay, then we got to combine like terms, right? So 2x squared plus x, so minus 4x minus 6 is less than or equal to 0. Ooh, I see something we can do to make our life better that we don't have to do, but we can. Divide by 2. You'll get the same answer if you don't do it, I promise. But that's going to make your life way better. X squared minus 2x minus 3 Oh, this one's way nicer than the other. This is more like what you might get on the test. This is way better than the last one. What does that break apart into? X minus 3, x plus 1. This is more like a real problem. I mean, the last one was super possible, and we got the right thing, but... So now we draw our number line, and where do we put the points at? Put them at -1 and 3. Yeah? 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 Everybody okay? We don't know yet. Oh, we do know they're going to be... Yeah, we do know. Fine. Fine. But I don't know which way to draw the bracket if I were going to start drawing the bracket there. I don't know which way to draw the bracket yet. Because
Well,
usually it's the same. I'm not drawing... Which parabola? X squared... Oh, Kristoff's so smart. Kristoff, you're genius. Kristoff's a genius. You know what Kristoff is saying to do the whole time for the last time? Talk us through this.
So you just draw the parabola as it should be. So it's,
How did you know how it should be?
well, it's happy and
It's a happy parabola. How did he know it's happy parabola? Right there. So draw a happy parabola.
yeah. And then just see, like you can just literally see when it's bigger than or equal 0 on the outside.
When is that? Wait, we don't want it to be bigger than 0. Look.
Outside, yeah. So,
But you know, it's,
I mean,
we're looking for it to be less than 0. Where
under the x axis.
where is that less than 0? Where is that parabola less than 0? The bottom, right? So right there.
And the equation is true for these numbers in this range.
That's a pretty smart way to do it.
I'm not gonna lie. I wish the book would have said that. True, accurate, works quicker. Why didn't the book teach that? No clue. Remember what the book told us to do back in the day? Check -5, check 0, check 6, and we did that because we drew that long table. And I was like, I don't like this table, so we graphed it. We graphed the original
Like,
thing.
this is just so much work for what?
The same answer.
Yeah.
Well, let's check it and see.
Well, you don't have to check -5. You just gotta check whatever's outside the bracket. Just check -2.
Oh, yeah. Why did I say that?
You're still working over something that you already know.
True. I'm just saying it'll work out.
Yeah.
I love it.
Yeah.
I love it. I'm gonna do that from now on. I'm gonna teach that next year.
You
Actually,
should do that, yeah.
I'm going to. Zero chance I will. Zero chance I don't. Now that I see that, thank you. That's awesome. Yeah.
So, like, the maximum is x minus 3 and x plus 3. Like, it doesn't become like x is less than 3, x is less than 3.
No, we're treating these as two separate problems. We're treating these as this is a. Watch this. I'm gonna erase the highlight. Here, I'll zoom in. This side is a polynomial. Ignore the rest of the problem. Let's factor that polynomial. This side is a number. That number is going to stay 0 forever. And those two things are unrelated. And at the end of the day, we're going to slap them next to each other and say, the left side, we want to be less than the other side. Like, we're not going to combine the three. These are three distinct things happening. And we're never even going to apply one of them until the very end. Once we got that 0 on the right side, we're done. So when did we end up getting a 0? After this step? After this step, we are just sticking with do the whole left side, do the whole right side, which is just 0 all the way down. And then at the end of the day, let's see what happens with that greater than less than sign. But you were saying, why do we put a less than inside of here? Kind of? Is that what you're saying?
No, basically, you're being like, why do we do that?
Right. You're saying that? Because this is a polynomial, and polynomial can turn into this. This is not a thing until the very, very end. And at the very, very end, we'll ask ourselves, where is that whole polynomial less than? All right, what else? We got plenty of time. We got a whole hour. The log thing?
Yeah.
Did I already copy it?
Yeah.
All right.
Is it number 7 also?
What? Is it graph it? I don't know. Oh, I didn't write it. I didn't write the thing. -1, comma,
Yeah, it says solve it.
3. That's the solve. That's the solution.
Yeah.
That's the set of solutions.
Oh, you use the
Because in this situation, the solution would, I guess you could say.
There's a bunch of them.
Yeah, there's a bunch of solutions. So you can say the solution is like the sort of the domain.
Mm-hmm.
of
Yeah.
this
No, absolutely.
problem.
Absolutely, the solution. The solution is the domain because the problem doesn't even have a y value, only x.
So could I write this instead?
Yeah. You could write x when x is -1 less than or equal to x less than or equal to 3. Set brackets.
The parabola with the graph for this function. Right.
Mm-mm. The problem only helps us identify the domain. The graph of this function is kind of wonky.
Oh, the graph.
If you're just solving for the following, why do you have to put the domain? Why can't you just put the x-intercept?
Because that would be if it were equal, not less than or equal to. The x-intercept is the x-intercept is the exact answer to the problem if that was an equal sign. So if it were saying equals, boom, you got it. That's the answer. But because it has that less than sign, it's like, well, there's a bunch of things that work. There's a bunch of x's that are true in this situation. But you're right, there's only 2 x's that are true if that's an equal sign. If that's an equal sign, there are only 2 x's you can plug in that are ever true. And it already is weird enough that you're allowed to have 2 answers, right? Like on a normal problem, it's a weird thing to say there's 2 x's, there's 2 x-intercepts. So it's no more weird to say there's infinite. It's what? No, that's the way somebody I've talked to. I don't know. It just stuck in my brain. But
The answer in that problem would technically be the domain.
yes, absolutely.
Just because of the inequality. If it had x equals the whole rational thing, then the answer would be.
All right, what's some laws? Some laws. Any law, we can go in any order. If you add, you multiply. I lied. Let's not go in any order. Let's do one of these other laws first. I should have thought about this. There's one law that's like,
So you take the exponent and you put it in front of log.
no, this is on the second review,
Oh, okay.
which is still important to do. What'd you say?
You take the exponent for the first logarithm and put it in front of it. So it's 4 times 4 log x.
But we're trying to simplify it. I think we need to take these and move them up.
Is that gonna make it simple?
I don't know. I guess simple is the wrong word. It won't say that on the test. I just typed really fast this morning.
It's either way, really.
It's either way, really. It should say, well, yeah, no, it'll say simplify or expand. The one you're looking at is expanded.
This one says simplify.
Yeah.
Okay, yeah.
The one you're looking at is already expanded. Now we're going to simplify. And technically that 4, it's actually not expanded all the way. This should say a 16 right here if it was fully expanded. So that 4 goes up there. Right? And we get log x 4 and then be careful here. Yeah, where are we going to put that 4 at? Are we exponentiating the exponent or the whole thing? We're exponentiating the whole thing, right? And there we have a law that we can apply. The other way, we don't have a law. We had this talk for a long time. Someone earlier this year. About why those parentheses matter so much. Minus log 8 to the 3rd. Plus log x plus 3 to the 4th. So then you get log x16. Log 8-3 log. Sorry, I just kind of rewrote. Second law. What's another law we can apply? Multiplication turns into addition.
Second and third term.
Yeah. It's kind of nasty. Turns into multiplication, right? So we've got the log of x of 16. I am trying to get rid of that minus. That minus sign is tough. That minus sign makes it tough, doesn't it? We got to do something with that minus sign before we can just go willy-nilly.
So it's basically -1 in front of logarithm.
Right, so we have to either raise that to the top. We have to either raise that to the top to get rid of it, or distribute another, I don't know, distribute another -1. We got to be careful. We can't, they have to, the logs have to look the same to combine them, right? The law is the log of A plus the log of B equals the log of AB, right? The law is not the negative log of A. So that's why I'm scared of that thing and have to be pretty careful. We can do the division first because that would get rid of that negative. But what I'm saying is we would get the same answer if we took that -1 and moved it up here and made that a -3. Don't you would get the same answer. It's really cool. No, it is. It's just so you get log of x16 divided by not log, just 8/3. Now we can do our plus because we got rid of that minus sign. Yay. The minus sign's gone right here, so we're allowed to do it. That's just an important note that it's easy. I looked at it too and thought, okay, well, can we just do this right here? No, because the minus isn't being applied to the whole thing. If it were parentheses like this, heck yeah, we could. But we can't. Plus the log of x plus 3, 4. So now if they're added, what can we do to them? x16 over 8/3 times x plus 3, 4.
Wait, I'm
Why
sorry.
is the log being added to everything? If it's just a minus, it would just follow PEMDAS, wouldn't it? Like you could just do -1 plus in whatever order. It shouldn't affect the rest of it.
Yeah, I'm thinking through why PEMDAS is scary and should now have arrows. I'm thinking now PEMDAS should definitely have, because of subtraction, this should be an arrow. Right there. It should be P, E, M, D with that arrow underneath it, maybe actually, because exponents is fine. And then this should be an arrow too.
I got a question.
You have to go left to right.
Why did you?
I know what you're saying, but I'm going to start teaching PEMDAS if I ever teach it with an arrow now, because you can't go you can't go in whatever order you want to, because that negative is not being applied. 2 minus 4 plus 2 is not the same thing as 2 minus 4 plus 2.
Well, the minus is stuck to the 4.
Right? This is 0.
It's basically 2 plus -4 plus 2.
So that's why I'm saying I'm scared of PEMDAS now, not being taught left to right, because those aren't the same thing.
So basically, we have to.
This one's 0 and this one's -4. It's weird, but that's the purpose of it.
Subtraction. You have to go left to right. And not just subtract, right?
Yeah.
Add.
Yes.
Can you go back to before you divided? So you did the first two logs first. Can you like square root to my square root, or like circle it?
This step.
So because you subtracted, you divided it.
Facts. That was the question? Oh, well, yeah, that's a great question. Yes. I was scared it was going to be way harder, and I was like, I don't know.
What if it was like a plus sign?
Then we would add them, and we'd have 3 multiplies inside of there.
Hey, can you write down what you did for the other class when you was like division, subtraction, multiplication, add?
No.
Yeah.
There's some basic. I didn't come up with this. They said this, but there's some basic log laws. There's more. Can you think of any more laws? Division turns into subtraction. Multiplication turns into addition. Exponentiation turns into multiplication by bringing it out to the front, not just like randomly. That's that whole log of a to the b turns into b log a. I shouldn't erase this too much though, because it's on a video. But Log of BB is 1. There's just some basic laws. If you think of any more, yell them and I'll add them. To what? 1 second. She's taking a picture. Okay. She's writing. These are so tempting. Cashews, sugar, and fat. Why? Why are all good things so bad for you? Why are all bad things so good for you?
When you say divide equals subtraction, or like goes to
Yes.
up there, what does that mean?
That means if you have division on the inside,
Oh, okay.
Yep. it turns into subtraction on the outside. But I'm looking for that one. You're going to ask one more question about this?
No. So x plus 3 to the 4 just stays like that?
X plus 3 to the 4. Yeah, no, don't foil it
You
4
can
times.
divide that.
Yeah. You could, what?
That's the final.
Yeah, that's it. That's what I would write. Maybe you could get rid of that multiplication sign by going log of x16 times x plus 3 to the 4th over 8 to the 3rd. Or if you wanted to multiply 64 times 8, you can. I don't want to multiply 64 times 8. Sorry. Yeah, what were you going to say?
So without the parentheses,
Bless you.
x to the 3rd plus log x plus 3 to the 4th. Then we have to start from the left, not just.
Yeah. Yeah. If we would have done the addition first, it would have been a multiply on that right side, and then the eight would have. If we would have done the addition first, it would have been multiplication, right? And then your plus 3 to the 4th would have ended up on the bottom.
Why are we about to add x plus 3 to the 4th to the fraction? Probably couldn't. Unless we made x over 8 to the 3rd.
I see what you're saying. Here's the
I
thought.
know that that's addition, but I just thought that you had to have it mentioned.
Right. That the way to see that in a little simpler brain wave is log of A plus log of B. I see. I know exactly. Yeah. Why can you put that on top of the fraction willy nilly when it was added? Log of A plus log of B equals log of A times B. And now in my brain, just literally label them A equals 8-3, B equals all that crap. And now I'm going to, without the log, multiply those two things, 8-3 times all that crap. And now I'm just going to throw that inside of a log. Whoops. Whoa. Careful. Hey, ever done that before, though?
Yes.
I've done it. No, I've done it. It's not pleasant. I just need to move this.
Can I do something real quick?
Please, dude. I know this is convoluted.
So, like the laws that you went over right now with that problem would
Mhm.
include that multiplication to addition, or addition to multiplication, right? And then division to subtraction. The reason why we had such an issue, or we had to be careful right here, is because with addition to multiplication, it doesn't matter how like you put it, because 2 times 3 is the same thing as 3 times 2.
Commutative.
Yes, but division is not the same thing. Not the same thing because 1 divided by 2 is not the same thing as 2 divided by 1. Correct? So it does matter the way we go about it. What you could have done when we got the same answer is we could have said, oh, like we wrote this and put this plus in the middle and have this at the end, and we would have got the same thing, but we couldn't have done like this first because this entire piece would have been at the bottom.
That's true.
That's not
That's true.
valid.
That's smart. You could have put the minus at the end.
Yeah.
That falls apart when you have 2 minuses. It doesn't fall apart. You just, well, no, you just still go left to right. Yeah, no, that works. Anyways.
Yeah, but for division to subtraction, you want to be careful because the order does matter, correct? Because the one on the left, right? Because it's left and right. On the left side of the minus goes on top. The right side of the minus goes on bottom, right? But for addition multiplication, it could be like this.
But if you're willing to give it the time, I will never tire of saying this. There is not one way to do a thing. The why matters so much more than getting the right answer. If you wanted to jump this whole -3 up here, you would get the same thing. I promise you. you'd end up with that x to the negative 3 and get the exact same answer. Heck, if you wanted to pull out a negative 1, if you wanted to factor out a negative 1 and end up with 4 log x to the 4th minus 1 parentheses, log 8 minus 4 log x plus 3, you'd end up with the same thing. Like, whoops. There's not one right way or wrong way to do it. And if you want to wrestle with it and see it, do it 6 different ways, get the same answer, be like, oh, I know how to do this now. I can see where all this comes together at the end of the day. Same way, Christoph's way of finding x-intercepts is way smarter than mine. Would we have both got the right answer? Yeah. He just got there 10 minutes before me. Like, actually, there's not one, like, it'd be dumb to factor out a negative 1, but I'd get it the same right answer. Okay, we got to use our time wisely. What else? Well, maybe not.
Yeah. Oh, never mind.
We just did logs. Just practice that C. That C's a good one to practice. 12? Ooh, that's fun and simple but weird. They didn't ask that first hour. That's good.
That one's. I don't know how it is.
That's cool. I like that question. Because it's either you know it or you don't. There's not a lot of, like, wiggle room. What is exponential form? Yeah, as an exponent, right?
See, I should have had a question with this.
Write the equation. A equals 3 in exponential form. So the exponential form has to be raising it, right? So what do you want to raise it to? Power of 1. Oh, well, no, that wouldn't be in exponential form. That would be with an exponent of 1. Right? So we go 10 to the A, e to the A. Is that helpful? You could raise it to E and raise it to E. Does that do anything for you? E to the 3 equals E to the A. Take the square root of 3. You talking about that right there? Or no? Oh.
Oh yeah, that's what you have to do.
Right. What you do on one side, you gotta do the other side. Watch me Google this. Exponential form of a number. Oh, it is E. Silly me. Exponential form of a number, 125. What? Mm-mm. Mm-hmm. No thank you to that. Huh. Bad.
It says it's already.
You're not
It's already.
What?
I searched it up and it said it's already like you can't do anything to it.
Okay, that's a good answer.
You couldn't take the square root of A equals the square root of 3, and then
Let's see.
in order to get rid of the square root,
You just square it, but then it get back.
square it back across.
Then you get A equals 3 again. It's pretty simplified. I just wanted it to be in. What about log of A equals log of 3? That's not helpful either because we just tend to get back to where we are. Huh. I will look it up and get back to you, but it won't. It's not on the test.
What I thought it meant was like when it said equation A equals 3, put it in exponential form. I just thought like having 3 as a base. I thought that it was like 3 raised to the x, but I was like,
Okay, so like 3 to the 1.
That's what I said.
That's fine for these purposes. But I'm gonna look. There's like a whole thing, a whole section skipped in our book about exponential form where they like write it as like. I don't even want to get into it. I don't want to confuse video watchers or me myself or y'all. I don't think so. Wait, really? Oh, then that's it. Holy moly! Thanks for. Why didn't you say that 10 minutes ago?
Because, like, for example, problem 15b,
Uh huh.
it's supposed to have like a negative x minus 5 after that.
Yeah, because this is the simplest form right here. Yeah, we talked about that last period. How b is in the simplest form. You can't do anything to it, which is a valid question to ask as well. Like, don't get tripped up and try to divide it when you can't. That's not a division, right? But will you tell me what this was so I can actually do it real quick, and then we'll move on? Oh, much better. Much better. All right, how do we write that in exponential form? Not a trick question. E to the a equals e to the 3. Maybe it's just the word latex typer screwed up, or I screwed up.
That problem was it the natural log of x squared minus 25? Right, that's what it was. The problem that he was mentioning.
Yeah, ln x
Yeah,
squared minus
it's in
25.
simplest form already.
So you would just write that.
Yeah, it's left alone. You
Did it
can't.
tell you to simplify it?
Yeah.
Like oh, okay, never mind. I was gonna say, you could expand it, no?
No, you can't do anything to it.
You can factor x squared minus 25 to x plus 5, x minus 5.
Oh, and then factor that in a plus sign.
Yeah,
Or
it would be natural log of x plus 5.
plus. Oh, that's fine. That's fine.
But if you said it's a simplified,
No,
then yeah, it would be in the
That's fun though. I like that. That's kind of cool. All right, what else? Hurry. That was a good question. Bad question on my part. Good question on your part. Nobody's done any of these pi things. These unit circle stuff. Okay. Okay.
D number 10.
Yeah.
Oh,
number
if
10.
we haven't done that already.
No, domain's good. No, domain's good, especially because if you go back and watch the video from the first class, we didn't do a whole lot of domain.
Yeah, no, that's fine.
So this is a good question. 3 things that make the domain bad. Go. They never change. We say them all the time.
Negative radical.
1 over 0 or number over 0.
A negative number.
Negative number here.
Log 0 less than.
ln of 0 or ln of negative number, right? Those are the 3 things. Which one do we want to do?
Okay.
This looks like a typo too. Are these ln's just not printing? It might be a printer or like a print to PDF error.
Or you just copy this.
Or I missed it. But that's like 3 of the exact same mistake where there's supposed to be an ln and the parentheses survived. So it wasn't like no, but what I'm saying is the yeah. Like if I was just a typo, I'd be like not even include the parentheses.
So the second one.
Weird.
Yeah, it would be that.
Okay, let's do the first one then. And if that is the ln, then it changes a little bit, but not too much. So the first one, there's only one thing that makes it bad, right? 2t minus 3 better be. That all rhymed. What? No. Greater than. Or equal to. Thank you. Dang it. Can't be 0, right? It's not square root. It's different than square root. It can't have a 0 on the bottom. Just greater than 0. And then you solve. 2t is greater than 3. T better be bigger than 3 over 2. That's it. That's the whole domain. So you can write nope. 3 over 2, comma, infinity. There's your domain. Good question. That's a good one. You know what that other one's supposed to be? John? Do you know what that other one's supposed to be? Sans typo? No, I'm just saying g of x I know is a typo. But we could actually do this. What is this domain? The domain of it the way it stands. It's a good domain to know. All real numbers. All real numbers are or negative infinity to infinity if you prefer. Because that's just a parabola, right? Good. It's a good domain to know. We should know that domain. Is that the question it probably was asking? Nah. It's probably an ln thing or a square root thing. But
So to find the domain of LN, we just leave the LNs.
to find the domain of ln, you just set it equal to better be bigger than 0. And that comes straight out of the graph of the exponential function and the log function and the ln function. If you remember, what does the log function look like? It crosses at 1, and it goes like this. What's the domain of that function? Bigger than 0. Yeah. Can't be, because it can be all these ones. Not when is that positive, but what is the domain? What is the x values can be? Similarly, the natural log function looks like this at e. And so all real numbers bigger than 0, which are consequently, if you remember back to our long thrall in inverse functions, you flip it across that line, right? And if we flip both of those across that line, we end up at this one. And you know what function that is? 10 to the x. And if we jump it up to e, you know what function this is? E to the x. This is ln of x. And this is log of x. They're inverses of each other, and their domains check out. That's the reason you can't have a 0 for an exponent. What's up? 10b? Well, yeah, it would change if it were log. You want to see? That's what I was asking you earlier. Did you look it up and see? It's supposed to be log? Perfect. Thank you. So what's the domain of this function? It did change. What do we know about the log? The log better be greater than 0. Not or equal to, because that would kill it, right? You can't have, I don't know the log of 0. I do know the log of 1, 0. Then I solve, right? X squared is greater than 1. Plus or minus x is greater than 1. X is greater than 1, and x is less than negative 1. Does that make sense? Should have just used Christoph's thing and I not even done that. No, for real, we should have. We've got negative 1 and 1, right? Graph the parabola. Is it happy or sad parabola? Going back to this step in the middle. This is what Christoph was doing that I didn't do. Is go back to this step and graph that parabola. Is that parabola happy or sad? So where is this thing bigger than 0? Right here and right there, right? Does that check out? X is bigger than 1? X is less than negative 1? It does check out. What's up?
So how do you know, like, put the plus or minus in front of the x and not on the right side?
You could put it on the right side. You would just have to know when you do the -1 to flip the sign. Ooh. You could put it on the right side. If you put it on the right side, though, I'm trying to find a place to write it. One sec. If you were to do that, do your square root thing, you go x is greater than the square root of 1, x is greater than plus or minus 1. When you do your little arrows and split that into two different equations, the -1 better take control because you did a minus over, technically you did a negative over the what's it called? Inequality. Because you did a negative across the inequality, even though it was dividing by a negative x. Negative x is still a negative number. So, because x squared is x times x, right? Or x squared is negative x times negative x. So technically you divided by a negative x to get x by itself. And because you divided by a negative number, your brain better thought, oh crap, there's a negative sign that just appeared on the right side when it was on the left side. I got to flip that sign for only the negative version, not for the positive version. It's got like 10 minutes.
Well, I just kind of got everything I need.
Oh, okay, we'll see.
No.
No, I'm just kidding. That's not nice. Okay, what else? We got time for one more, and I'll take roll in a second.
I got one. Well, it's not like one that you guys saw. I just got a question.
Yeah.
On number 9, when you say sketch the graph of each function and state its domain range and so do you mean like what do you mean by that? So
Sketch the graph of each function and state its domain, range, and asymptote. Show the x-intercepts and y-intercepts in the graph. So I literally mean for each of these, I would do the x and the y-intercepts first. It just
Okay.
makes it easiest for me. So I plug in 0. Like here, I can do the first one pretty darn quick. So y-intercept. This is the one I do first. You don't have to do what I do first. This is the one I do first. Y-intercept. Whoa. Actually, here. I'm sorry, but this is important. And if you need to leave, no. Sorry. No. We can do this in 5, and then I can take a roll. I'll just do the top one, though. And then I'll post all this video and all these notes and my first video and the first notes all online. So hopefully it's a little...
Sorry, do you got a video for the second test review or just the first?
Yeah.
Okay.
All this. Everything I've done today for the 4 hours I've been here. I record. Like I'm recording right now. Okay, so y-intercept, I plug in 0. Y-intercept, f of 0 equals 2 to the 0. Holy crap, what just happened? No can do. Can't have a 0 up there. I don't even know what that means, right? Wait, yes I can.
Yeah.
Why was my brain bad?
I was like, hold up.
1 plus 4 equals 5? That's the point 0, 5? Someone could have just had a free donut. They would have stopped me. Sometimes you get brain farts, and then
Zero, negative zero, the same thing.
sometimes you get brain farts and you got to fix them. X-intercept, what do you do? You set it equal to 0, right? 2 negative x plus 4 equals 0. 2 negative x equals negative 4. 1 over 2x equals negative 4. I don't know if that was helpful.
You knew what you could do.
Yeah, log 2 it.
Oh yeah, I was also thinking because 2 4 related.
Mm-hmm.
Oh wait, never mind.
Log 2 it, right?
Yeah.
Log 2 it.
That was
Kills that, you get negative x, right? Log 2 of negative 4? Ooh, what's log 2 of negative 4? It's like log 2 of 2 to the... Or negative 2 to the 2? No. No.
yeah, it would be a negative 2.
No. That's
And
4.
You just don't put parentheses.
Oh, negative 2 to the 2? That's true.
That is.
That's true. So I can move that 2 to the front, right? Oh, this is log 2. Oh, this is getting uglier than it needs to be. Is there a better way to do this one? Log 2 of negative 1. Holy crap. We can't have the log of a negative number. Right? Boop. What'd you say? Oh, I was going to keep going. I was going to split these and say log 2 of negative 1 plus log 2 of 2 to the 2. I was about to split them up because the negative 1 times 2. But right away, I should have seen right here, you can't have that. Right? You can't have the log of a negative number. So there's no x-intercepts? Interesting.
Oh, yeah, that does.
There's no x-intercepts.
That does make sense.
That does make sense because we know what this graph looks like.
Yeah. Oh my goodness. How did? Yeah, that's true.
That does make sense because we know what this graph looks like. So that's the x-intercepts and the y-intercepts are done. Domain range, asymptote. It has 0, 5, right? Boop. 0, 5. Do we know what the graph of 2 to the negative x looks like? The graph of 2 to the negative x. Is this like an exponential graph? Or is this like an exponential decay graph? It's like decay, right? So it's going to look like that. This 0, 5 is in the way. Does it ever go negative is the question.
I mean, like, is the K graph
Because the negative sign, yes.
exponential?
Mm-hmm. And is there an asymptote?
Wait, so what did you just grab? 0 over 5?
0, 5 is the y-intercept because we solved for it. There's no x-intercept because that line never hits x. I know for a fact that I don't hit it. Actually, that doesn't even hit another line. What line does that also not hit? It's going to get super duper close to 4 and never go past it.
Remember how the original.
What's fours are like?
X, y equal 4 is probably a y asymptote because we shifted the regular asymptote of the exponential up by 4. No x-intercepts. No y-intercept, or one y-intercept. Shifted up. Reflected across the y-axis from the normal thing. And vertically stretched by a factor of 2. So if I wanted to plot one extra point, it could be the point -1, which would probably be 6. -1, 6. And I could plot the point 1, which would probably be not a pretty number. What's 4 plus 1/2? 4. Thank you. 4.5. And those do kind of center around the 0.5, so that's nice. You want to go plot more points, feel free. But
More of a transformation problem. Right?
it actually is like a transformation problem than a start from scratch and build your way up. But if you don't remember the transformations, you can start from scratch and build your way up. Okay, let me pause this so I can take